Kauna. Yeah.
Okay. Good evening, everyone. It's a pleasure having everyone here. Well, I'm the web lead for GDSC. I'm at the Bello University, and we'll be getting into the introductory part of front end development. And I want us to be attentive. And I also hope that we came with our questions to ask. And if you have questions along the way, please, I'd like you to, wave your hand or stop me in the middle or something. Just let me know when you have questions, okay? So I'll share my screen now and then we'll get started. Okay. Sorry about that. Trying to. Okay. So can you see my screen?
Yes, we
Yeah,
can
yes,
see
we
it.
can.
Yes, we can see
Okay.
it.
Okay. So um we'll be having the introduction. So our first topic will be the introduction and how the web works. And then from what I've written here, we can see that HTML files, um, HTML files have browsers that request from servers frequently, and they have link elements that point to external CSS style sheets and script elements that point to external JavaScript scripts. So what this simply means is that for those of us, so I'll ask us to have some applications installed like VS Code. So when you have your VS Code editor and you create your HTML file and everything, you have to link it to your CSS style sheets. But then even after linking it to your CSS style sheets, you also have to connect it to your JavaScript, and your JavaScript also enables it to enables the website to work. So it's JavaScript that goes behind the scenes and makes everything work. When the browser loads the website, it's critical to understand the order in which these files are analyzed. The browser initially passes the HTML file, which enables the browser to identify any references to external CSS style sheets and scripts in link and script elements. As the browser decodes the HTML, it sends requests to the server for any CSS and JavaScript files. It discovers from link and script elements. The browser then decodes the CSS and JavaScript from those files. So as we know, for HTML and CSS, the only way to run it will be on your Chrome browser. And then when you run those files, it connects to your CSS. But then your CSS is what you use to style your HTML files. I would like to apologize because I should have added something visual so that everyone can see what how it works. But then also go to the next slide, which is the web architecture and how the web works. So from what we can see, that's if you can see my screen, you can see the web request and the responsive circle of how everything works. So we have the front end, and then we have the client side, and then we also have the web browser. But then we also know that the web browser connects to the web server and then also connects to the storage. So, for those who are front end developers, they work basically with the visual side of things, how the application works, the usability, the responsiveness, and everything. But then for the back end devs, they get to work with, how. Okay, let's say for example, now you have your login page. You can see where to input your name, your password, and everything, your date of birth. But then your back end developer will now make sure everything that you input will work behind the scenes. And then for those who go into, DevOps, you get like the cloud storage and everything. The second slide on architecture, we have the users, and then the front end, basically everything, file system, database, SQL for those who are into data science and all that, and then everything. So what is front end development? According to what I've written here, Front end development is the area of an app or website that users directly interact with, and which is known as the front end. The software developer needs to have a variety of abilities in order to develop on the front end and everything with user experience and everything. So basically, what front end development is, how users interact with the website. For those who are majorly into user experience and user interface design, they basically tell you, okay, you have to know how the layout works, what the contrast is, the simplicity. And then some people will tell you, minimalism is key or minimalism is king and all that. So we're going to who is a front end developer. And according to what I've written, the front end developer is the person who is in charge of creating the layout or schema for these kinds of apps. And the front end development encompasses the building of mobile apps or applications in addition to traditional development strategies and processes. The foundation of front-end development is HTML and CSS, and front-end developers use frameworks or packages like Angular, Vue, React, Bootstrap, and etc. So basically, what it says is that a front-end developer is somebody who creates the schema, who creates the layouts, basically who works with the user experience and everything of a website. So we'll get into front-end frameworks, and some of the major frameworks for front-end are React, Vue, Angular, with React being one of the popular or the most popular, followed by Angular and then Vue. But then the common argument with front-end developers over the years has been which framework is better than which. And for those of us who have been active on Twitter, every day or almost every day, you get to see the arguments. React is better, Vue is better, Angular is better. But then the key is knowing which one works for which, and what advantage, and you weighing the pros and cons and knowing that, okay, yes, I prefer to work with this because it has this, and I don't like the cons of this. So according to the creator of Vue, Ivan Yu, who worked in Google for AngularJS before creating Vue.js, he talks about his process for making Vue.js, and it goes like this. I figured, what if I could just extract the part that I really liked about Angular and build something really lightweight without all the extra concepts involved? And then I also attached a link to the documentary, where he talks about how he created Vue, in his spare time and while he was working at Google. But then we also know that from the story of Angular, that people at Angular didn't really like JavaScript like that. So they decided, oh, let's extract something from JavaScript and create something really simple, since we don't understand Angular. And then now we have things like TypeScript coming in. Okay. So the next thing I would like to talk about is React. And one of the creators of React was Jonathan Walk, a software engineer at Facebook. And he developed React and published an early version of it under the name Fax.js. It was influenced by XHP, a PHP library for HTML components. And in 2011, it was introduced to Facebook newsfeed, and in 2012, it was introduced to Instagram. It was made publicly available at JavaScript conference in US in May 2013, at Facebook's React conference in February 2015, React Native, which enables native and all that. So, um, for those of us who are quite, knowledgeable about frameworks and everything, I would like us to, go back and make some research on these people. Try to see, okay, read up on their stories, go to Wikipedia, try to see, okay, how did they come up with these things? Because most of them, as you can see, were just side projects. They just went on and said, okay, let me just create something. In my free time, let me just try to build a project, and then they create, projects that eventually stay for a lifetime or outlive them. Um, so we go into what is responsive design and what is adaptive design. So responsive design, the use of mobile devices for online browsing, is expanding at an incredible rate. Yes, these devices frequently have limited display sizes and necessitate a different approach to information organization. According to Ethan Marcot's initial definition in a list apart, responsive web design adapts to the needs of people and the devices they are utilizing, depending on the size and capabilities of the gadget. The layout alters. On a phone, for instance, consumers might see content presented in a single column perspective. So basically, what responsive web design is that it works with how how um how your website displays on major devices. So for the common device we have mobile phones, which most people use or most people have access to, and then we have medium devices, maybe like iPads, tablets, and all that, and then we have our desktops and all that. So basically, what responsive design does is that it makes sure that your display of your website is adaptable to each device you use. But then what's the difference between responsive design and adaptive design? We know that responsive design modifies the rendering of a single page version, in contrast to adaptable design, which does not. Contrarily, adaptable design offers numerous wholly distinct iterations of the same page. So I'll go to the next slide and show us what an adaptive design is. Sorry. So for instance now, when we look at a responsive design, it is universal and it flows across each display. So we can see that in our desktop, in our mobile device, in our tablet, it all has the same display. But then we also see that in our adaptive design, the displays are different for each device. For as it gets smaller and smaller, the display gets different. For instance now, um some people argue with me that the display for Facebook on mobile and Facebook on desktop is different, a bit different, and the display for Instagram on mobile and Instagram on desktop is a bit different. Then we go on into design principle. Some of design principles are contrast, and contrast basically describes how various elements are arranged in a design and how they stand out. So we can see that you can see that for certain websites, when you go to certain websites, you get to see how the colors. You might not necessarily see it. For instance, I know that when Facebook was gradually developing Facebook into what it is now, they hired psychologists, to come and talk about how design works, how colors affect your brain. So you can see that in some major social media platforms you use, they use cool colors like maybe blue or eye-catching colors like red, just to make it look, just to make the users attracted or captured. We also have things like balance, and we know that in design we have the typeface, the colors, images, forms, and patterns, and also the visual with how it affects the users visually. Is it light to your eye? Is it catchy? Does it balances everything? Is it symmetrical and all that? Another design principle will be emphasis. The components of a design, are they intended to stand out? Are they the subject of emphasis? We also have proportion, and proportion basically refers to the size. Is it proportionate to different things? Is it proportionate to how the users interact with different components? Like, okay, um you might say, okay, this, let's say a button now, a button and a login button and a submit button, or a login button and a sign up button, does it align and all that? We also have hierarchy, and basically is the design guideline that affects how well a content is absorbed by visitors, and it speaks of the significance of design components. We also have repetition. You also want your users to come on and see that, okay, your so how do I explain this? Your it For repetition, you can talk about, okay, so I know like in design there are instances where you have like the Z. So what your users first look at when they log in, what they look at next. So you also have that alignment. Um Lastly, I want us to know our why, and web development, or coding or software development is a lifelong process. Like, you have to keep on learning and learning every day, and technologies come up every single day, on almost every single day. People keep bringing technologies for us to advance and make things easier. So you just have to keep learning and learning, and being patient with yourself and not compare yourself to anybody. um I'd like us to end with a quote by Steve Jobs, which says that sometimes when you innovate, you make mistakes, and it is best to admit them quickly and get on with improving your other innovations. And it says a lot about your career path, or your process, in web development or software development, or whatever path you take. That you keep on making mistakes. I remember when I first started learning React, I, I wasn't saving my file, so it just kept on. I just kept on working and working and working. It doesn't making sense. So I just had to keep on going and going. And even sometimes when you run into errors, you get frustrated, you get annoyed. You don't talk to anybody, you don't want to eat sometimes. But well, um, the last slide is where I left resources for us to go to. We have W3 schools, Free Code Camp, YouTube, um, Uderica, Travesty Media. So you basically get to practice on your own and learn on your own. And please, if you have questions, don't forget to redirect them to me. Okay. Please, does anyone have a question? Sorry, can you hear me?
I said we will have a Q&A session at the end of this call. Towards the
Okay,
end.
okay, that's fine.
All right. Okay, are you done?
Oh, yes, I'm done.
All right. Thank you very much, Anna, for this wonderful presentation. So the next thing on our agenda is, how can I do this? Can I make you uh the host? I have to be uh admitting people that want to join me.
Okay, okay, that's fine.
How can I do that? How do I do that? I think I will just go ahead with the presentation because I couldn't figure out how I I can make you the host. So, good evening, everyone, once again. And I'm Abdullah News. Just reintroducing myself. I'm Abdullah News. I'm the technical lead for ABUG DSC, and I'll be giving us a quick walkthrough uh, of back end development and also introduce us to the back end track that we will be having at GDSC ABU. So, let me share my screen. I think I will need to make you a host before I start presenting. People keep coming, and how do I do that? See? Okay. Excuse, please, can you or like mute your mic. Excuse, please, can you mute your mic if you are not talking? So, this is the introduction to the back end track. So, we will start. So this are what I'm going to cover in this session. I will start with what is backend development, some concepts and important things you need to know about backend development. Then move on to backend development with JavaScript. As we all know, JavaScript was not intended to be a backend language. It was intended to be a front-end language, but somehow some cool people developed something with it. Now you can use JavaScript to build your servers. And after that, a quick overview of the backend track, and then setting up the Node.js command line application, a simple command line application with Node.js, just to give you a feel of how Node.js is used to build applications that are not going to run in the browser. So, hi, someone is not muting his mic. Okay, all right. So, what is backend development? So this definition I got this definition I got from IBM says backend development means working on server side software which focuses on everything you cannot see on a website. So, meaning as a back end developer or someone who's working on the back end, you ensure you work in the background, but you ensure that a website performs correctly by focusing on the database side of the software, the business logic, the APIs, the servers, and the architecture of the software you are working on. So, an example would be let's say you are in a restaurant, right? So you went to a restaurant. The first thing they do is they will present you with a menu which you can use to select food from, right? So after selecting a food, the waitress or the server, yeah, the waitress will take your order and go get the food, but you don't know who cooked the food. So that's where the back end is. The chefs that you don't know who are responsible for cooking your nice meal uh, is an example of how the back end is. So, important things or concept that you should know in back-end development. So the first one I have here is application programming interfaces, which are also known as APIs. So what are APIs? APIs are a set of rules that define how devices or application can connect and communicate with each other. So they are set of mechanisms that enable two devices to communicate with each other in a standard way. So let's give an example. If APIs were never invented, let's say for example you have a website and APIs were never invented. So you as a developer will be responsible for defining how uh, any brand or any operating system that wants to access your site, you as a developer will be responsible for defining how that operating system or brand that is accessing your site with you as a developer will define how they communicate with your site. So imagine now creating a different logic for users that are using iPhones, and different logic for users that are using Infinix, or and different logic for users that are using other brands of. Imagine all those brands that we have. You are creating a different logic for them. Then that's automatically an overkill. So this is why APIs are very important. They standardize how communication happens between two devices. So when those brands, be it iPhone or Infinix or any other brand, are creating their devices, they will have to make sure that their devices support those API standards. So once they know that they have that feature, then you as a developer only need to create one software, one way of communication, and all those different brands, all different operating system will be able to communicate with your application seamlessly. So this is why APIs are very, very important. So some common examples of API protocols, we have the REST or RESTful API. I think this one is the most common. It's widely used, and I think as a backend engineer, you would probably be dealing with RESTful APIs. Then RPC, this one too is also very common, but this one is mostly used in a microservice architecture. But we will come to that. Then there's SOAP, which is also another protocol in the standardization of how different devices communicate with each other. So the next item we have is the concept of databases. So what are databases? So databases are collection of structured, semi-structured, or unstructured data. So at some point when you are building your application, you will need to collect some sort of data and store it for later use, or because your business needs those data. So that's why database too are really, really important. So some examples of data that you might need to collect at some point are user information. This could be when a new user is signing up on your website, so you will need to collect maybe the name of that user, his email, password, and things like that. So when the user comes back, you will need those data to authenticate the user. So other data that you will most likely need site metrics or user behaviors. So this type of data are usually, sorry, let me just admit some, I'm sorry for that. So as I was saying, other types of data that you will probably need to collect are site metrics and user user behaviors data. These data are sometimes are really important, most especially when you are building a, let's say for instance, you want to build a strategy of advertisement. So you have users that come to your site and spend only let's say 5 minutes and leave. So you want to target those users specifically so that they would, the next time they visit your site, they will spend more than that 5 minutes. So in case of advertisement, you will need data. So these are data too that you can collect from your site, and you will need somewhere to give them, uh, which is why database is there. So we have uh, some types of data that databases, but the most popular ones are relational database or SQL database, and NoSQL or non-relational databases. Okay. So relational databases are databases that or store data in a tabular form, that is a data that contains rows and columns. So in a relational database, your data is structured. So examples of relational database are Postgres, SQL, and MySQL, and there are others too which you can probably later go and check out for yourself. But I think these two are very popular among developers. So for unstructured data, they are those that are that the data does not conform to a specific schema. That is, it doesn't have a definite shape. Your data does not have a definite shape. Hence, you cannot store that data in a row column format. So this is where unstructured or NoSQL database would help you store your data. So the most common ones, no, uh, no, these two are part of the most common ones, which is MongoDB and CowDB. Although, of course, there are other ones, but these two are very, very popular among backend or software engineers in general. So the next thing I would like to talk about is the architecture and backend development. So the architectures and backend development means design styles or patterns to structure your application. So these are design styles or patterns that you follow, you abide by to structure your application. There are industry standards too. So we have the monolithic architecture, we have the microservices architecture, we have the decoupled. I think this one is very popular among developers nowadays. This is the emergence of front end libraries or frameworks. Then we have backend for front end, which is BFF. I mean, this one abbreviation is very funny. BFF. You know, if you don't know about this, you will think that BFF is best friend forever, but BFF actually stands for backend for front end. So the monolithic architecture. So in the monolithic architecture, uh, you you build your software in such a way that all the components that make up your software are assembled and tightly coupled. That is, all the components that make up your software are strongly dependent on each other. It's just like putting all the components in one big container, so all of them are dependent on each other. A major advantage of this one is it's easier to host. It's easier to, I think, build as a maybe as a startup. It could be, yeah. So, but the major disadvantage is this monolithic architecture is not fault tolerant. That is, if for example, a single component in your application is having a fault, that means all the application will go down with that single component that is having a fault. So you can see that this one is since they are very dependent on each other, they are not fault tolerant. Their fault tolerance is very, very low. So we have the microservices architecture. So the microservices architecture is a situation whereby a single application is composed of many many decoupled and independently deployed deployed smaller services. So in microservices is just like a mirror of monolithic. Instead of putting everything in one container, you have different services deployed in different servers. So, and they are highly independent on each other. So for example, is let's say you are building an e-commerce site. You are building an e-commerce site. So in that e-commerce site, services of your e-commerce site could be one, authentication. You want to have a service that will authenticate from registration to login. You want a service that will do that. You uh, you can have another one like the product service, which will hold which will be in charge of adding, removing, and things like that of products that are sold on your application. Then you can have another service like let's say authentication. You have the product, you maybe a checkout service, a service that will handle all checkouts. So you can see that you have three services, but at the end of the day, all these three services will come together to power your application, which is that e-commerce site. So when the authentication site, for example, if the authentication service is having a fault and is down, but remember that you have three services. You have the product service and you have the checkout service. That means only the authentication service is down, but the other two are still running. That means the only users that we will be having problem accessing your sites are those users that want to register at that moment of failure, or users that want to log in back into your site. But the users that are already logged in can continue using your software, can continue using your website to buy products, since the product service is still running, or check out since the checkout service is still running. So from this example, you can see that microservices architecture is is fault tolerant, since if one service is down, that does not affect the other services. They can your application will still continue to deliver services. But the major disadvantage of this microservices to monolith is that if, for example, from our example, we have three services which are deployed independently. Maybe you deploy them on, maybe let's say AWS, which is Amazon Web Service, the cloud provider. So you will have three instances running, one instance for uh, each of the services. So since we have three services, we will have three instances running. So you can see that the cost of hosting a microservice architecture is higher than that of monolith, because a monolith is just like a big container with all the services, all the components in one place. So all you need to power of a monolithic application is just one server. But in the case of microservices, you can have as many servers as you have. Yeah, you can have the number of servers you will be needing will be equal to the number of services your application have. So and hosting, spinning up a server will cost you. So there are charges attached to that. So instead of paying for only one, you will be paying for three in this case. So the next one is decoupled, which is front end and back end. I think this one is one of the most popular one nowadays. It's very trend. It's trending. Yeah. So in this type of architecture, you build your server, your back end differently from your front end. That is, you decouple your front end from back end. So you will have your back end maybe stored, yes, hosted on DigitalOcean or any hosting provider, while your front end too will be hosted in somewhere separately. For example, let's say you have an application built with React.js. So since React.js, you build the front end entirely with React, and let's say you have the back end in Node.js. So the Node.js back end can be hosted on, let's say, AWS. Then your front end can be hosted on Vercel or Netlify, which are uh, very common to front end developers in terms of hosting nowadays. So you see, you have your front end decoupled from your back end. So when the back end, the yeah, when the back end is not working, your front end would work, but the APIs will be down. So and when the front end is down, the back end will still uh, be on service while you get the front end before. Yeah. So the next one is backend for front end, which is the BFF. So in this in this architecture, you build more than one backend instance to handle requests from different users of different devices. So this is not like the microservice architecture, though it will look like the same. But in this case, let's say you have a website, and you have a back end too, but your back end will basically you have, let's say you have a large amount of data that you want to send to users whenever they make a request to your back end. So you know that users that are accessing your site with a phone have smaller screen. Hence, the presentation of the data you send from the backend will be harder. So, and the users that are accessing with a laptop have a larger screen. That means easier representation of the data. That is easier display of the data. So since you have large amount of data that you want to send back to the user whenever they make request to your backend, so you can have two separate backend. One will be handling the requests that are coming from users with mobile phones, and the other one will be handling requests that are coming from users with larger screen, with laptops or computers in general. So in this case, whenever a user is accessing your website with a mobile phone, since you have a different server to handle all these requests, the data that will be returned to that user will be a fraction of your total amount of data that you intended to send back. But when the user is coming from a laptop or a PC in general, then you can send the whole data. So this is why the back end for front end tool is somehow cool. So with that, we can move on to our next subtopic, which is JavaScript for backend using the JS to build servers. Yes. So as you all know, JavaScript was initially built for front end development. So, but after JavaScript had gained momentum, after a lot of developers have used JavaScript and are in love with the language, the some cool people, some cool developers decided to build uh, decided decided to bring JavaScript out of uh, the browser to the backend, so that we can use JavaScript to build back-end application. Imagine if you are only a JavaScript developer, uh, before the invention of Node.js, you can only do front end. But now with Node.js, after learning JavaScript, you can basically do full stack. You can do the front end and do the back end with the same language. So that's why Node.js is very popular, and it's an important technology. So what is Node.js? Node.js is a free, open source, and cross-platform JavaScript runtime environment that let developers to write command line tools and server-side script outside a browser. So basically, Node.js lets you use JavaScript to build application that can run not only in browsers, but that can run in terminals or servers. So some important things that I would like to talk regarding Node.js is the V8 engine. The first one, the V8 engine. So what is the V8 engine? So the V8 engine is basically the engine that compiles your JavaScript. Is the engine that runs your JavaScript code. Once you click run, this engine will be the one in charge of running your JavaScript. So it is It is an open source technology that was built by Google, and it was built for Google Chrome. So you know Google Chrome is the browser that Google has. So it was built for Google Chrome to run JavaScript applications. So the the inventors of Node.js, or the creators of Node.js, decided to leverage on that V8 engine, since it is an open source technology, which basically means you can use it without paying a dim. So they leverage on this technology to build the runtime environment for JavaScript to run in the back end. So the next thing I will like to discuss is single thread. So JavaScript is a single threaded it's a single threaded language, which means uh, when you send a request to JavaScript, what it does is it put all the requests in a queue, that is in a queue. Yeah. So after putting all the requests in a queue, it will process each and every request one at a time. That is, it cannot start processing two or three requests at a time. It will put all the requests that are going to the yeah, all the requests that are coming, it will be passed into a queue. So there's this concept of FIFO, it a FIFO, which is FIFO, first in, first out. So queue is a data structure that the first thing that enters get processed first. So there's this other opposite concept called the stacks. The stacks is just the opposite of queue. In stacks, the last thing to enter will be the first to be removed or to be processed. The concept, what was the abbreviation for it? The stack uses LIFO, I think, yes, last in, first out, LIFO pattern, yeah. But for Q, it's for FIFO, which is first in, first out, FIFO. So single thread JavaScript, all requests that are coming will be put in a queue, and the first one that came will be processed before the next one. So JavaScript is a single threaded language. So Node.js as a runtime environment for JavaScript is also a single threaded. So that means no matter how many requests you send to your JavaScript application, all that request will be handled one at a time. So this is the concept of a single thread. Although there are workarounds where you can leverage on the amount of cores you have in your PC or in your server to run multiple cores instead of a single thread with Node.js, but that is kind of advanced. Well, it's out of the scope of this introductory session. So the next thing is the model controller views. Model controller views, yes. So this one is like a way to structure the logic of your application. It's a way to structure the logic of your application. So the first one is the model. In this part of the structure, you write all the logics that have to do all the logics that have to do with data, from accessing database and processing maybe data. You write all the logic that are associated with data. Then the views, yeah, the views is like the representation layer. It handles all the logic of what you want to present to a user. Then the controller is the business logic layer. So what the controller basically does is it stays in between the model and the views, and all the requests that are coming come through the controller, and the controller decides after checking the logic of the request out. After checking the route that the request was sent to, we'll decide what to do. Let me just uh, admit it. They are okay. Someone is trying to do. Okay. So yeah, as I was saying, the controller sits in between the model and the views and controls all the business logic, that is all the requests or that are coming to your application. So the last thing here is Express.js. So Express.js is a framework. It's a Node.js framework that lets you write server logic quickly. It's very easy to use, and we will be using it in our subsequent classes in this track. So yeah, so introducing us to the track, the backend track. So our classes will be bi-weekly, and it's going to be project based. That is, we will be building project as we are learning, and all theory will end by December, because there's no much theory in Node.js, sincerely speaking. As far as you are good with JavaScript, then there's no much theory in Node.js. Just practically applying, building things would go a long way than spending much of your time reading the theories of Node.js. So as far as you are good with JavaScript, then there's no any reason to delve completely on theory. So the classes will be project, and all updates will be posted in the backend WhatsApp group. So I think that's what. Okay. As before I end the, I would like to quickly build a simple Node.js command line tool so that you can get a hang or on how Node.js is used to build application. It's going to be very simple. So let me stop presenting and present again. Can you see my screen?
Yes, we
All right,
can.
all right. So let me quickly create a folder. Let's say demo. All I'm trying to do is open uh, VS Code in that folder we just created, the demo folder. So the first thing is to create a JavaScript a JavaScript application, a JavaScript file. So after that, let me do a simple console.log. So let's save the file. So the first thing is to check whether we have Node.js installed. As you can see, I have Node version 16.17.1. So that means I have Node.js installed. So to run a Node.js application, all you need to do is type node, then the name of the folder you are trying to run. So when I do that, you can see it's console logged ooh, welcome to just fixing the typos. So after running, you can see, as you can see, welcome to the demo is printed on my screen. Check. So as you can see, the first thing, uh, so normally in in JavaScript, you cannot, you will not have access to, you cannot have access to the server or the host in this case that is hosting your JavaScript file, since since your JavaScript only run on browser, so you cannot have access to the to your architecture of your PC or the internals of your host. So, but with Node.js, you can do something like that. You can say OS. I can access my OS directly. So if I do something like, if I do something like, say, like something like, let's say we do something like hello, then the name of the user OS, just get the user info, username, then your OSS. Let's do something like OS. So with normal Node.js, you cannot have access to your OS internals, but with Node.js, you can see that what is being printed on my console is hello developer, and this developer is the name of my UD, is the name of my user when I log into this computer. So and the name of my computer is mainnet. So your mainnet is, you see the architecture, I'm using the 64-bit Windows, so I can basically access the internals of my computer with Node.js. But with normal JavaScript from that runs on the browser, you cannot do that. So basically, this is our simple command line Node.js application. I did warn you that it's not going to be something crazy. It's something very basic. So this is the end of this. So let's go back. I think, do we have anything else? Okay, the summaries. So summaries, we introduced back-end development, where we talk about things like APIs, databases. We talk about architectures. We move on to talk about architectures, the monolithic, the one with single container, microservices, the one you, or that is highly fault tolerant. We did decoupled, which where you have front end separated from back end. The and also the backend for front end, the BFF, which you can have two servers, one responding to requests from users that are using their phone to access your site, and the other one for users that are using their PCs, since PCs have larger screens. So after that, we gave a quick introduction to JavaScript. We gave a quick introduction to JavaScript and Node.js. Then the simple command line tool we built at the end of this session. So I think that's basically it for today. So I will stop sharing my screen. So that brings us to the Q&A session. So if you have any question for either of us, you can do well to ask that now. We will do our best to see that we give the best answers we can come up with, or if we can't, then we will note your questions down and give you updates on the group. And don't forget to join the back end development group if you are here for the back end track. It's very important because that's where all the necessary updates will be posted in. So if you have any question, please you can ask now. You can unmute yourself and ask, or if you are shy, you can drop the message on uh you can drop the message in the comment box. Yeah. Ahmad Ali, you can go on and ask your question.
Hello, can you hear me, please? Yeah, hello, can you hear me?
Yes, yes. Go on, ask your question.
Okay. Thank you very much, Mr. Yunus and Ms. Kauna. That was a very wonderful presentation, and it's talk through. My question is, you were talking about building of projects of recent, and I want to ask, what of those of us who are new into development? Will there be any scratch kind of course for us to begin our journey with? I'm sure when it comes to either front end or back end, we don't go into JavaScript. I think it will start with HTML and CSS, as the case may be, before moving into JavaScript. And I want to ask if there will be kind of a consideration for us who are actually new into development. That's basically it.
Kauna, are you going to cover from the basics in your track?
Okay. Okay. So, if you're new to back end, I'll definitely advise you start with, a bit of front end so that you understand how the interface works and how everything works.
Yes.
For resources on how to get started, I uploaded the slides to a folder on Google Drive. So I'll just share the link on the group chat for the front end guys. And then, when you go to the end of the slide, there are links where, you know, I included links to websites where you can learn, basic tutorials. Hopefully, you will start building projects, you code along and then you learn also. If you're not much of a visual person, if you need books, I'll also try to upload them on the Google Drive.
All right, thank you.
Okay, thank you very much, Connor, for the answer. So, if anyone has any question, you can ask now before we end the call and call it a day. If you are shy, you can drop your question. Oh, I can see someone had already done so. Sorry, please. I want to know if Node.js can be used for both front end and back end. Node.js is not a programming language. It's a runtime environment. It's just an enabler that allows you to write JavaScript for back-end development. So if you are, so if I'm to rephrase your question is, uh, you want to know if you can use Node.js for both front end and back end. So as I said, Node.js is not a programming language; it's a back end environment that lets you run JavaScript application. So, but you can use JavaScript to write both front end and back end applications. So if you can be able to learn JavaScript very well, then you can use JavaScript for both your front end and back end. So your full stack application would be in JavaScript, and you can see how already an advantage that is. So learning JavaScript is very essential. It's very important. It's I think it's the easier path to becoming a full stack software developer. So Sunusi AZ, if you are still with us, then learning JavaScript is what would enable you to do both front end and back end with the same language. Node.js is just a runtime environment for JavaScript, not a new language in its entirety. So I hope that answers your now question. And someone, if you would be able to, sorry, he asked, is it advisable for one to take the two track at a time? Well, I assume, I presume that you are an Abosite, and we all know that ABU will not start lectures until January the 3rd. So if you can maximize these remaining weeks that we have, like I said, for the back end part, we will be done with all theory by December. So for the rest of the semester, we will just focus on building projects. So if you can maximize this break before school activities fully resume in January, then you can do the two tracks simultaneously. But you have to know that the efforts that you would put you will invest will be more than that of someone who would only partake in one track. So I hope that answers your question. So you have another, okay, thank you very much. So I think if there's no any other question, well, before we leave, Kawana, do you have anything to add?
Okay. I can see somebody asking in the chat box if
Yeah, yeah.
there's a roadmap for back end development. Yeah.
Are
So I
you?
think there's this website. Just Google
Okay, so Lucy is it? Yes, of course we have a roadmap. I will be sharing the link to the roadmap in the backend uh WhatsApp group. Are you already a member of that group? If you are not, then you can let me see if I can just share the link to the backend group real quick, so that if you are on this call and you want to join, you can actually do that. So it's loading, it's taking time. Okay, so this is the backend invitation link, WhatsApp invitation link. You can use the link to join our WhatsApp group. Kauna, can you quickly share the one for front end, so that if anyone,
okay, okay.
so after that, then we can round up and call it a day.
Okay, I just shared the link for the front end.
Okay, let's wait for 9:51 to end the call. By then, if anyone wants to join either of the group, we'll have done that. So we will be ending this to learn PHP. Okay, is it advisable to learn PHP or Python first for backend development? Yeah, it totally depends on you, on what you want to uh, use for your backend development. PHP is good, Python too is good. Uh, for example, myself, I learned PHP. PHP was my first backend language, but I didn't do much with PHP. I didn't jump to JavaScript, and I also learned Python, building backend servers or APIs with Python. So, but my main stacks are in terms of backend development, Python and JavaScript. So I don't really use PHP now, but a lot of people are using PHP and are enjoying it. So for Python, if you learn Python, there are a lot of cool frameworks you can use, like Django. Django is very good. There's Fast API. There's yes, like yeah, Flux. There's also Python Flux. There are. will go. And if you take the PHP part, then you can learn something like Laravel or Code Igniter and things like that. So it really depends on what you want to do, but uh, either either one. If you chose to learn PHP, it's good. Python too is good. JavaScript too is good, but it's easier to learn Node.js if you already have experience with front end library like React or Node.js, React or Vue or Angular or several or things. So if you are coming from front end and you know that you are very good with JavaScript, then learning Node.js is the easiest path you can take because you won't have to learn another language to be full stack. All you have to do is know how Node.js structured its logic, and you are good since Node.js is actually JavaScript. So if there's no any other question, then we can end the call now. Thank you very much for joining. Thank you, Kawana, for the wonderful presentation. We I so let's have the best week. Get rested, and yeah, do what's best for you. Thank you very much, everyone, for joining. You can unmute. Oh my. Okay, let me just take a quick screenshot of this. I don't know if Kawana, have you been taking these screenshots?
Not screenshots, but I'm recording. But I can take a screenshot now.
Right. Okay. So bye bye everyone. Have a nice weekend. Thank you very much for joining. Thank you, Alivi. Shall I just end the call? I want you to gracefully exit the call before I. So it's 9:55. So thank you very much, everyone, for joining. Kawana, you can stop recording the screen. I'll be ending the call.